derivatives. So you're still going to be calculating derivatives every single day, and you're going to be practicing those like crazy. Okay? So if you have those down, you're going to be able to focus on the next level, which is applying those derivatives. Caleb. Okay, so we're going to be applying derivatives until Christmas break. Some of them are work problems, but mostly it's still a lot of pure math calculations and analysis, and then we put it into some context. Okay, so we did talk about this last year in pre-calc. We all should have. Okay. So if you're given a function, do you remember the difference between local and absolute minimum and maximum? And so if I ask you what this point would be, okay, what kind? Local or absolute? Okay, so this is an absolute max because nothing else is above it. Right? It is the top. Plain and simple. Okay. What about this one? Yeah, it's an absolute min, because, again. Okay. How about, yeah, that would be a local min. And then this would be a local maximum. Okay. Those are the framework for today and tomorrow. Okay. These three are called critical points or values. Some people call them critical values. Okay. We call this, so that critical points or values are where f prime of x equals 0. Right, because we have a slope of 0 here, right? And a slope of 0 here. Correct. Or f is not differentiable. Right there. There's a cusp, right? We have to consider where f is not differentiable. Okay. So that we have done all the calculus related to that, correct? We've talked about not differentiable, we've talked about where f prime equals 0. Okay. Our focus today is just on local mins or maxes. Okay. There's a test we use called the first derivative test. When we get to considering absolute mins and maxes, we use a different test. It's called the candidates test. Okay. So we're just going to worry about the first derivative test today. Right. So, and we're just going to do that algebraically. All right, so we're going to focus on algebra today. Right. Good? Think you got it? That's not what I wanted to do. Okay. Let's does this, so I think we'll hold that for tomorrow. Okay. Let's just do a couple examples, I guess. And So let's find the critical points. A polynomial. That's a polynomial. Is there anywhere that it's not differentiable? Remember what cubics look like? Your parent function knowledge? Yeah, this is going to look like that, right? Is there anywhere that it's going to be not differentiable?
No.
Okay, so this is differentiable for all real numbers. So we don't have to worry about that one condition right there. Okay. All we're going to have to worry about is derivative equals 0. So,
You derive that one?
what is the derivative? Yeah, I'm assuming.
Minus 18, what are you supposed to do?
Okay. There's lots of mumbles. There's just a power rule, right?
You said that equals 0?
Yep. So critical values set equal to 0. And how are you going to solve that problem? Yeah, if that's a quadratic, your first thing is to factor. Remember that? Okay, what can I factor out of that?
4. Verse 6.
3? Yeah, your greatest common factor, remember? The greatest common factor first, divide by 3. That's not dividing by 3, that's dividing by 2. Well done. 6x plus 8, right? Can you factor that? Lots of mumbles today, but I think I'm hearing you. Correct? Oh yeah. And what are our x values? Those are your critical points.
So would that mean add 2 and add 4? That's an absolute minimum.
Okay. No, we're not doing absolute. So, okay, if you look, remember what the graph looks like? Do we have any absolute min-max? No, because these go on forever in both directions, right? So, all we're looking at is a local min and max. Okay. But have you answered the question? Find the critical points? Yeah, you did. Okay. So, if that's all you're asked to do, you're good. Okay. Know your algebra. That's a good thing. Okay. There will be, let's call that, questions that say, determine if the critical values are a min, a max, or neither. one possible way to ask that question. Can you, knowing what the graph looks like, can you kind of guess? Right, so 2 will probably be a max, local max, and 4 is probably going to be a local minimum, right? But we have to verify that algebraically. So, this is called the first derivative test. And the best way I've found to illustrate it is to draw a number line with 2 and 4 on it. And we're going to analyze values here, here, and here to see whether the slope is positive or negative. So we'll use this right here. So what's f prime at 1? Right, because 1 is over here to the left. So what is the slope of f at 1? So that's -3 times -1. Positive. All we really are concerned about is positive or negative. You do not need the actual number. Okay, so all this that we just did, you don't have to do that. All you need to know that it's positive. Right, so that means that the function is going up to the right, correct? Okay, so f is increasing. You remember that vocab word? Okay, what about f prime at 3? Three minus 4 is negative, and 3 minus 2 is positive, so we get a negative. Down to the right, f is decreasing, right? So, increasing to decreasing. The critical values of min or max. Yeah, the function goes like this, right? What we have is a function that goes like that. We have a max. At x equals 2. Okay. What do you think about the other one?
5.
F prime at 5.
Sorry, so
5 minus 4 is positive, and positive we get a positive. Means it's increasing, so the function does this number, and we have a minimum at x equals 4.
and that's all we do is to do.
That's it. You just determine that this is a local max and a local min. Okay, using the first derivative test. Okay, so beyond what you've already done, setting f prime equal to 0 and solving, This is called a sign analysis. It's the first derivative test. But we use sign analysis in several different situations. This one just happens to address mids and maxes. Okay. Look easy enough? Sure. No. So, looking for local min-max, set derivative equal to 0, do a sign analysis. Okay. Let's look at a different one.
Not funny, dude. Right, Mr. Murphy.
What?
You're not cheating, you're not trying. Right?
I hate that. Now I want to hurt you.
No, you love that.
No, it's just what I want to do.
Well, I perceive that.
Yeah, well, your perception is not correct with my intent.
Well, because we had to talk to Mr. Locke, doesn't matter about intent, it's all
It does.
perception.
It does
Go to
matter.
jail.
The author has control of the text, not the reader.
I'm gonna pull that one up on court.
All right, so critical points of absolute value of x. So the first question you asked, are there any places where that's not differentiable? Where? Yeah. Okay. So that's going to be a critical value, or critical point. Okay. And we're going to do our sign analysis if we want to find local min or max. Do we need to calculate the derivative of that function? Because remember our critical points, not differentiable and f prime equals 0. But do we need to calculate that derivative?
What is the derivative of the absolute value of x?
There's your critical value. Are there any other possible spots? No. So we don't need to bother with the derivative.
What is the derivative of
In order to, so side note, that's a good question. The derivative relative of absolute value. Okay. So you know what that critical point is, right? So we have to split this into two different functions. Okay. It's a piecewise function. On the left side, what's that function? It's the negative. Right? And on the right side, it's positive. So all you do is split it at the critical point, or where it's not differentiable. Left side's negative, right side's positive. Now you can calculate the derivative. Yeah. So g prime of x is -1 and 1. And you can see that in the slope, -1 and 1, right? This also tells us why this is not differentiable at 0. So there's your side note on absolute value derivatives. You good with that? Oh, it's good job. Yeah, it's almost time. Whoops. Okay, how do we determine local min-max? Sign analysis, right? So G prime at -1 is negative, and at 1 is positive. We see the slope's negative, positive. This tells us we have a local min. Right? Is that an absolute minimum? It is. Yeah.
Is it like the same thing with a square become equal to a local min and can also be an absolute min?
Yeah, that would be an absolute. I'll show you how to, you can use this information to determine that's an absolute, because there's only one transition. But the candidates test is another way to do it. So, okay, so there you go. Critical points, local min-max. Are we good?
Sure.
Okay. You must not neglect this practice because it is important. There's not very much. Again, you're practicing derivatives and finding critical values.
What lesson is this from?
It's 4.2.
4.2?